Okay, we have here today another integral from the UNSW integration bee, CPMS 2023. This was semifinals round 1, problem 3. We have the integral of ex plus 1 over e to the 2x plus 1 dx. Okay, and I think this is a perfect example of why you shouldn't integrate when you're tired. I tried this one last night and it didn't work at all. I didn't know what I was doing, and then I did it this morning and it wasn't too bad. So what I think I want to do with this for my first step is, because we're adding in the numerator, I want to split this into two integrals. So for my first integral, we're just going to have ex over e2x plus 1. And then we'll take this 1 and we'll just split it into another integral. So we'll have the same denominator here. And then for this first one, we can do a u substitution. For the second one, I would really like to have something in the numerator so that I can do a substitution on this one as well. What I can do to create that is, what if I just multiply by 1? We can multiply by e to the minus 2x over e to the minus 2x here and distribute that in. So when we do that, now we have something in the numerator. We'll have e to the minus 2x dx. E to the minus 2x times e to the 2x gives us e to the 0 or just 1. And then we'll just have here 1 times e to the minus 2x. And now I think we're set up where a substitution is going to work on both these. So for my first one, I'm going to do a u substitution. I'm going to call my u equal to e to the x. And then so if we take a derivative, du is going to be just ex dx. That's great because that's exactly what we have here in the numerator. Then for the second substitution, we'll use different variables. So I'll do v. So I'm going to set v equal to the whole denominator. So we'll say v equals 1 plus e minus 2x. I'll take a derivative to find dv. Derivative of 1 is going to be 0. Derivative of e to the minus 2x is going to be minus 2 e minus 2x dx. And then we'll just go ahead with this. So when we do this, again, here we're going to have du in the numerator. E to the 2x is going to be the same thing as u squared. So we're going to end up with u squared plus 1 here for this first one. Now for this second integral, we almost have our du right here. If I multiply by minus 2, now this is exactly our, not du, dv, sorry. But I don't want to change it, so I'll multiply by minus 1/2 out front here. So minus 1/2 times minus 2, we're just multiplying by 1. So now we'll go ahead with this substitution, minus 1/2 out front, again dv in the numerator, and then our whole denominator is just going to be v. But these are going to be two really simple integrals, so this is just going to be arctan. So for our first one, we're going to have arctan of u, and then for our second one, we'll have minus 1/2. This is actually just going to be natural log absolute value of v. Let's see if I have enough room for the solution right here. So for the final solution, just doing our back substitution, we're going to have arctan of u, which is just e to the x, minus 1/2 natural log of v, but v is just going to be 1 plus e minus 2x. But this here is always positive, so I'm going to remove my absolute value on this, and we'll add a plus c, and that's it. But one last thing before I finish up, in the answer key, they have the solution in a slightly different form. I think I'll just manipulate this a little bit with algebra to try to get it into their form. Okay, what I'm going to do with this is just going to work with what's inside the natural log and try to manipulate this a little bit. So I can actually write this as 1 plus 1 over e to the 2x, but then writing 1 as e to the 2x over e to the 2x, I can then add these two together. So this is going to give me e2x plus 1 over e to the 2x. But now putting this back into natural log and rewriting this like this in this new form, but then with a fraction inside the natural log, I can rewrite this again as ln e2x plus 1 minus natural log e to the 2x. But then I can take this exponent here out front. When I do this now, when we put the 2x out front, this is just going to become natural log of e. The natural log of e is just 1, so that's going to go away. So now to finish this off, I'll just take this and we'll plug this back in here for our natural log. So when I do this, it's going to give me, we'll just copy down the arctan e to the x. This part doesn't change. Then we'll distribute in this minus 1/2 natural log e 2x plus 1. Then just multiplying minus 1/2 times minus 2x, that's just going to give me plus x plus c, and that's it. So again, both these solutions are fine, but this second one matches the UNSW answer key. So we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a good day.